we'd like to introduce you to the Meyer Sound Leopard 900 LFC system, the most recent addition to the Leo family of products. The Leopard 900 LFC system is designed and engineered as a linear system. With its linear approach, Meyer Sound introduces a paradigm with the Leo family product line where the sound reproduced is accurate, predictable, and scalable. This means the quality of audio being reproduced will not change as the system output level is varied. This allows mixers full control of the content reproduced, being able to listen to the source, not the system. When arrayed, the Leopard and 900 LFC elements have a combined response that is immediately usable, natively, without applying presets or other signal processing for a number of configurations. Just loop the signal from the console to the 900 LFCs and through to the Leopards. Obviously, for more complex systems, signal processing will be used. The system size, power, and performance make Leopards and 900 LFCs ideal to use in almost every application, from a main system in a theater to a fill speaker at a sporting venue. Here are the details. Leopard is the mid-high element of a system that includes 900 LFC low-frequency control elements, the MDM signal and power distribution system, and Galileo Callisto array processors. The loudspeaker components are self-powered. The amplifier modules include true power limiting circuits, electronic crossovers, amplifiers, and the remote monitoring probe points and data card. These are all optimized for combined system performance. Each of these loudspeakers become a building block that, when combined together, give the system consistent and predictable results. Removing variations in processor settings, differences in amplifiers, and long speaker cable runs, while eliminating the guesswork of matching amplifiers and transducers, contribute to making these systems efficient and easy to work with. Here we can gain a sense of size. The horizontal coverage pattern is wide, allowing for broad audience coverage. The vertical coverage and throw distance are determined by display angles and number of elements in the array. The user panel provides audio, power, and RMS connections. There are either 5-pin XLR connectors, where pins 1 through 3 are the audio signal input, and pins 4 and 5 are used for the RMS data network, or 3-pin XLR connectors for audio signal input and loop-through. To supply power to the Leopard, use a Neutrik PowerCon 20 cable mount connector. The power can be looped from one Leopard to the next using a cable with PowerCon 20 blue and gray connectors. Up to 10 can be looped together on a single 16-amp 230-volt circuit, and up to 6 on a single 20-amp 115-volt circuit. The power can be looped from one 900 LFC to another as well. Up to 6 can be looped together on a single 16-amp 230-volt circuit, and up to 4 on a single 20-amp 115-volt circuit. The rigging accessories allow for several configurations of the system. The MTG Leopard grid is used to connect motors to either Leopards or to 900 LFCs. The 900 LFCs can be rigged to form a gradient directional array, which requires the signal of the rear-facing elements to be polarity reversed and delayed. The center bar attachment points can be used for single-point rigging. The grid can be used to ground stack both Leopards and 900 LFCs. The angle foot allows for 3 to 8 degrees of down tilt when used in a ground stack configuration. The PBF Leopard allows for pullback to achieve down tilt beyond what is possible with the grid alone, and can be used to increase the down tilt of the Leopards by being added to the link of the 900 LFC when in a ground stacked configuration. The MVP motor V-plate is used to adjust the panning of the array. The caster frame is used when disassembling arrays and to transport up to 4 Leopards at once. The 900 LFCs can be stacked 2 high on the MCF 900, 4 high and 3 high Leopard covers, and 2 high and 1 high 900 LFC covers are used to protect the grills and user panels during transport. Transporting of audio signals, IP network control, and RMS data between front of house and the loudspeakers will need to be planned for. The MDM distribution system offered by Meyer Sound is an efficient means of distributing power, audio signal, and RMS data for the entire system. There are additional tools and equipment that can be considered when using a Leopard system. A computer running Meyersound's Compass software or an iPad with Compass Go is used to make adjustments to the Galileo Callisto array processors. For system verification and calibration, a dual-channel FFT measurement system such as SIM3 can be used to verify signal polarity, timing, spectral content, and to perform transfer function measurements of phase and frequency. The grid angle defined in the map design can accurately be measured and achieved when trimming the array. An inclinometer with a remote reader with a plus or minus 0.2 degree tolerance will provide the needed accuracy. To accurately measure seating planes on site and input them into the Meyersound MapXT software, a laser rangefinder inclinometer is used to measure from a reference point to the beginning and ending of a seating plane. The laser rangefinder can also be used to trim the array at the appropriate height. The distance from y equals 0 to the bottom of the array is displayed in the Flown Loudspeaker System Properties window. For flown arrays, appropriately sized and rated motors, wire rope, shackles, motor controllers, and the interconnect cables will be needed. This is the basic product information of a Leopard 900 LFC system and the associated accessories. Please refer to the operating instructions, assembly guides, and other documentation available at meyersound.com, or email technical support for additional information.